Good.
10.3, you do not need your journal. Let's get this done quickly. Jordan, can you hit the right light switch for me, please? So today we're going to be doing a few different theorems involving chords. So let's just refresh our memories here, and this will be on your quiz as far as vocab, what a chord is. A chord is a segment that starts and stops on the circle. So let's look real quick at the difference between, pay attention, a diameter and a chord. A diameter has to go directly through the center, so it's like a halfway point of the circle, and then a chord does not have to go through the center, so it kind of splits the circle into a minor arc and a major arc, okay? And today we're talking about chords. We'll talk a little bit about diameters as well. First theorem here says in the same circle or in two circles that are congruent, like the same size circle, if two minor arcs are congruent, then the chords that created them are congruent as well, and vice versa. It's an if and only if theorem. So if you have two chords in a circle, in other words, two different chords that are the exact same length, then the arcs that they intersect also have to be the exact same measure. So if this chord was 10 and this chord was 10, and then you knew this was 70 degrees and I asked you to find this one, it would be 70 degrees because they have to be the same. That's the first theorem. Pretty straightforward. So this first problem says, in the diagram, the circles are congruent. What makes two circles congruent again? Because we have to know this for our quiz. What makes two circles congruent? Same size, but what make them the same size if they have the same what? They all have 360 degrees. It's good. I mean, it's a fine guess. The same radius, whoever said that is correct, okay? All circles have 360, but if they're the same size, then they have to have the same radius or same diameter. So these two circles do. If you look at this radius and this radius, they have the two tick marks on them, marking that they are congruent to each other. So the circles are congruent. They say FJ, whatever length this may be, is congruent to JK. If that's true, that means the arcs that they intersect also have to be the same measure. So then it says, what's the measure of FG? And who can raise their hand and tell me what that would be? Sam? 80 degrees. If these two segments are the same, then their arcs are the same. And so if that's 80, then FG is 80 as well. So don't overthink a problem like that. The first three problems on your homework are like this. If it looks easy, it probably is, and that's okay. Okay, there's theorem number one. Second theorem today involves a chord and then a diameter. So the theorem says if the diameter of a circle is perpendicular to a chord, it has to be perpendicular. That's the key here. Has to intersect at a right angle. When it does, if it splits a chord, it splits the chord into two equal halves. So FD would be split into FH and HD being equal. And then it also splits this arc that it's intersecting in half as well. Okay, so as long as the diameter is perpendicular to the chord, it splits the chord in half and it splits the arc in half. And then vice versa. If you were to happen to know that the two pieces of the chord are the same, then this has, and that this is a 90-degree angle, then this has to be a diameter. But the key here is it has to intersect at a right angle. If it doesn't, then this doesn't apply. This one does. First of all, where's my diameter up here? Who can raise their hand and give me the segment that's the diameter of this circle? Heard from Jordan today. Thank you, Jordan. I've heard from Sam. Kylie? JL is the diameter because it goes through the center. HK is just a random chord. So since the chord and the diameter are perpendicular, since they intersect at a right angle, that means the chord is being split into two equal halves, and then this arc that it's intersecting is also being split into two equal halves. Okay? First problem says find HK. Who can raise their hand? So Cassie, can you get off your phone? That would be helpful. Thank you. Find the length of HK. Who can raise their hand and tell me how long HK would be? Cassie? 14. If NK is 7, NH has to be the same. 7 and 7 plus 7 is 14. Find the measure of arc HK. Well, before we do that, we probably need to solve for x. Now, again, since the diameter is perpendicular to the chord, HJ and JK, those two arcs are the same. So what can I do with those two expressions? Set them equal. Okay. Now, it's a two-step equation. Minus the x over, we get 10x equals 70. Divide by 10, and x equals 7. Now, the arc measure is not 7 degrees. 7 degrees would be like super, super tiny. So what do you think we need to do with that 7? Plug it in, somebody just said. Now, we're looking for the entire arc h to k. Okay, if I plug it in here, like 11 times 7, I get 77, which is good, but 77 is only from j to h. So what would I need to do to get h all the way to k? I didn't understand what you said. What? Double it. Or people earlier said plug it into this one and then add them together. If your brain works that way, that's fine as well. Either way, so you can plug it into both expressions and then add them together, or plug it into one of them and then double it. Questions on that? Okay. So a little check for understanding here on both those theorems. The first theorem said if you have two chords in a circle, two different chords, and they're the same, then the arcs that they intersect, AB and BC in this case, also have to be the same measure. Okay? So the first one says if AB is 110 degrees, find BC. Someone I've not heard from yet. If AB is 110, find BC. Joe, what do you think BC is? Any guesses? 110. That's exactly right. They have to be the same. So if AB is 110, BC is 110 as well. Now, number 2 is separate from number 1, so the 110s are no longer there. This one says if arc AC is 150 degrees, find arc AB. Do we have any ideas? Andrew? Where'd you get 210 from?
150 minus 260.
Okay, so he's thinking take a full circle, 360, subtract off what you know, and you get 210. Now, if I only subtracted off the AC, then the 210 is A all the way around to C. So now cut it in half because the two pieces are equal to each other. And you get 105. Good. Questions on the first theorem? Second theorem, if the diameter cuts the chord at a 90-degree angle, then it cuts the chord in half. So here's your chord CE, it's cutting CE in half, and then it's cutting the arc that it intersects into two equal halves as well. So the first one says find the length of C all the way to E. C all the way to E. What do we think? Emma, what do you think C to E is? No guess? Don't know. Tiffany?
C all to E?
Huh? It'd be 10. Because if C to E is 5, if C to F is 5, then F to E is 5 as well, because they have to be the same. And then C all the way to E is 10. I was telling my other classes, and perhaps I've been watching too much Walking Dead recently, but when I look at this picture, I think of like a crossbow. I know this is weird, but like this is like the stem of the crossbow, and then the crossbow cuts like the bow part in half, and then also the, never mind, I'll just stop talking about it.
Do what you're saying, you get like arrow.
Thanks. Yeah, little Darrow action. All right, arc CE. Arc C all the way over to E. First thing I should do here is solve for x. What can I do with the expressions again? What can I do here? Set them equal. 9x equals, I covered up my own writing, 80 minus x. Add x to both sides, you get 10x equals 80. Divide by 10, and x equals 8. Now again, the arc measure is not 8 degrees. 8 degrees is like this much. So what do I do from here, Avery? What?
No?
Plug it in
Plug it
first.
in first, wait, and
So we need to do 9 times 8, which is 72, and then I can double that.
I know.
Okay, question so far? All right, our last little theorem here is called the equidistant chords theorem. Equidistant, we haven't heard that word in a while. What does equidistant mean? Equal distance. So it says, in the same circle or in congruent circles, two chords are congruent if and only if they're equidistant from the center. So these two chords here and here are only congruent if and only if these pieces from the center are the same size as well. And it works both ways. So if you know that the little pieces in the center are the same, then you know the chords are the same. Now, remember, distance from a point to a line, like if I draw a line and a random point here, the distance from a point to a line, if you're like, well, where do I measure, is always at a 90-degree angle, always. That's why you're seeing these little right angles here and here, okay? So our first problem with that. In the diagram, QR equals ST, which are both 16. This is going to be crucial information, so make sure you pay attention to the directions. So it says QR is 16 and QR equals ST, which is also 16. They're both 16. So since those chords are the same length, the distance from the center to each chord, those little pieces in the middle, have to be the same as well. They have to be. And I tried to make like little GeoGebra files for this, but I couldn't get them to make chords on the GeoGebra, so. Our goal here is to find the radius. That's our goal. Now remember, a radius, any radius, can go from the center to a point somewhere on the circle. So there's infinitely many options, but we're either going to want to look for C to S, C to Q, C to R, C to T, and you'll see why in a second. Now, probably need to solve for X first. We're going to do this in like a 3-step process, basically. Let's solve for X first. If those chords are the same, then these little blue pieces in the middle are the same. So what can I do with those two expressions, do you think? Set them equal again. So let's go ahead and set them equal. Be careful on your algebra. I have a lot of people, once again, trying to move all your x's and constants to one side, and then your balance tips over. You got to move your x's to one side and your constants to the other. So if you're going to move the 2x over, you need to be prepared to move the 9 back over to the other side. That's why I just go ahead and move the 5x over, because now the 9's already on one side and the x's are already on the other. Divide by -3 and we get x equals 3. Now again, the length of that little middle piece is not 3, that's just x. What do I need to do with x to find the length of these middle pieces? Plug it in, and you should get the same answer. Here, 2 times 3 is 6, and then here, 5 times 3 is 15, minus 9 is 6 as well. So that little blue piece in the middle is 6 units long. And you want to find a radius. Your radius goes from the center to a point on the circle. We're going to create here a right triangle so we can use Pythagorean theorem. So I'm going to connect this center piece to one of these 4 points. It doesn't matter which one. I'm going to choose S. Because when I do that, I've just created a nice little right triangle that I can do Pythagorean theorem on. Okay, this length is 6. I'm looking for this length. This is your hypotenuse right here. C to S, center to the circle, that's your R, that's what you're looking for. Now, B to S, let's talk about this. B to S, we just learned, If your radius or diameter intersects the chord at a 90-degree angle, it splits it in half. So if the whole thing is 16, what's half of 16? 8, so VS would be 8. So now what you're looking at is a right triangle where the right side is 6, the bottom is 8, and you're looking for the radius. And you would do Pythagorean theorem. Okay, go ahead. We'll pick up here when you get back. Okay, we're back at it. Sorry, I got my recorder going again. Here we go.
Howdy, partner.
Wait, can they
Where are we
hear
at?
us?
What?
Can they hear us?
It's just like a video.
There's no sound?
Yeah.
Oh,
What?
They can hear us.
So they can hear us talking.
Yeah, how do you think the video can hear me? It's not like Skype, you guys. It's not FaceTime. I'm recording my
I know,
lesson.
but like, it can hear me talking.
Yes.
100%.
Hello.
Okay. Here we go. Let's finish this off. Finish this off, please. Hey, come on, guys. I need your attention again. So we got a right triangle here. The 6 came from solving for x and then plugging it in. The 8 came from being half of the chord, which is 16. And then your hypotenuse is what we're looking for. So we're going to use Pythagorean theorem here. 8 squared plus 6 squared equals r squared to solve for the radius. 8 squared is 64. 6 squared is 36. Let me get out of the way. 64 plus 36 is 100. R squared. If 100 is r squared, what is r? Sam?
10.
10. Because you squared it. And that's your final answer because you want the radius, which is what you just found right here. That radius is 10. Okay, let's do one more like that. Can I keep going?
Yes.
If you're still writing, just be honest with me. Like, nope, please wait a second. Anybody starting? Okay, so here it says J, K, and LM are both 24. You have to know that to do the problem. They're both 24. So if those are congruent, we just learned in that equidistant chords theorem that, oh, please be quiet though, guys, please be quiet, that the distance from the center to each of those lines is the exact same length. So what's step 1? Set them equal and solve for x. So that's step 1. 3x equals 7x minus 12. I just got lightheaded all of a sudden.
Maybe we don't need
I don't have my concussion. Minus the 7x over. I'll be just fine. I'll power through, guys. Don't worry. Divide by -4. And x equals 3. Okay, but that's not the blue length, right? You still need to do what with it? Plug it in. So pick one of them to plug into. It doesn't really matter. I'll pick the 3x. 3 times 3 is what? 9. So both of these little pieces are going to be 9. Now again, I'm looking for the radius. So I'm going to draw in a radius. You can draw it wherever you want. You can draw it from the center to J, center to K, or center to M, or center to L. You just got to make sure you're drawing in a right triangle so that we can use Pythagorean theorem. Okay, in that right triangle, the right side is 9. That's what I just found. Plugged in x and I got 9. What's QL going to be? What's the bottom of this triangle going to be? Who can raise their hand? And, excuse me, tell me. What's the Q to L going to be? Kylie? 12, because if the entire thing is 24, half of 24 is 12. And then you're looking for the radius r. Your r in these cases will always be the hypotenuse. Always. Just an FYI. So then again, Pythagorean theorem, 12 squared plus 9 squared equals r squared. 12 squared is 144, 9 squared is 81. (144 plus 81 is 225. That's r squared. So square root. And what do we get? 15? Now those problems will be whole numbers, and when I say that, I promise I'm not lying this time. On the worksheet, they really are whole numbers. I promise I'm not lying.
I believe you.
Thank you. Can you please, Andrew, sit down. Can you please get out your 10.3 worksheet?
Oh, I think I have a sneeze coming on.
Andrew, I could see you being like the type of person that's in the movie Sandlot. You know, like when they have that bat on, they're like, "Your mom's kid, whatever." Or no, you play mom, good girl.
I could see Andrew using that as an insult.
What do you say?
She said they'll call me a cyclops.
Okay.
Freaking, I have feelings
Honestly,
too.
I'm mad I didn't think of the curse.
Your eyes are not that close together. They are normal distance apart.
Then why can't I only?
See, I am like really self-conscious about my like forehead being really large, and everyone's like, "Your forehead is a normal size. Why are you concerned about it?" I'm like, "It's huge." It's just funny what we think about ourselves when everyone's like. Anyway, see now you're all looking at my forehead because you're like, "It is really big."
Forehead. Or like 7 hit.
Even if it is, you gotta embrace it. Do you?
Exactly. Can't change your forehead. That'd be weird if you did. So.
Ew,
Yeah, no, if you hold your hairline.
Doctor, I'd like a smaller forehead, please.
What if you just like fell on your head and it smushed your head?
Ow! Wait, Andrew, what? If my head's smushed, then something's wrong with my skull. And I am probably dead now, so.
No. That's actually not anymore. This dude had a giant indent in the side of his skull.
Yeah, my friend Faith got into a car accident and she was like, it dang.
Yeah, but that's probably because they took a piece of the skull out.
Like, when she hit her, like, she didn't go to the hospital or anything. It's just like, it not, like, she had a problem.
She had a problem.
No.
Okay, guys, can we get this started? Because we're going to do number 10 together. So get your worksheets out in front of you. 1, 2, and 3. This is a typo. Mine looks a little bit different than yours because I had to fix 2 and 3 from today. So it says, find the measure of the red arc or chord. I'm very well aware that you can't see red when it's black and white. I get that. That's why I put these there, so that you would know what I'm talking about. However, on 2 and 3, I didn't put the right symbol. So on number 2, your guys' looks like a UV with an arc. It should be a UV with a segment bar. I know arc UV is 34 degrees. That's not what I'm asking for. And then number 3, you're looking for segment QR. Okay? Please don't overthink those 3 problems. All right? If this is 75 degrees, this is 75 degrees. So don't overthink it. We are then going to jump down. You only have 10 problems to do here. We're going to jump down to number 10. Because 9 and 10 are like what we just did, but 10 is slightly different because the algebraic expressions are in a different spot this time. They're not marking like the middle lines. So we are given in this case that the middle lines are the same size. So that means that these 2 chords are the same distance from the center, which means they have to be equal to each other. They have to be. So we're going to start it the same way. We're going to set the expressions equal. It's just a little bit different than the other one because, like I said, they're in a different spot. So let's solve for x here. Minus 4x. Add 6. 10 equals 2x. Divide by 2. X equals 5. Let me pause. All I did was set the expressions equal and solve. That's all I did. X equals 5. Now, 5 is not the length of the chord. What do I have to do with the 5? Plug it in. So it doesn't matter which one you plug into. What's 6 times 5?
30.
30. What's 30 minus 4? Sorry, 30 minus 6. 24. Sorry. Okay, 24. All right, we are looking for the radius. I'm going to draw in from Q to C a little radius here. That's what we're looking for. So this right here is 5. That's just straight up 5. How much would this be right here? Half your chord. 12. And so you're looking at a little picture, a little tiny skinny triangle where this is 5 and this is 12, and you're looking for the radius. And then you would do your Pythagorean theorem, which I have faith that you can finish on your own. But that one was just a tiny bit different than the other one because of the placement of the expressions, okay?
Okay.
There is really no reason you have 14 minutes that you should not leave here today with this not done.
Can I go to the bathroom?
1 second. So try and get this one, and then remember tomorrow. It would help me out a lot if somebody, one of my lovely student leaders, could take initiative and collect these tomorrow and binder clip them. You should get it done in class today. So if you're thinking like, no one pick them up because then we don't have to do it, you're gonna have to turn them in at some point. So if you get it done today, if you could turn it in tomorrow, and if somebody could just walk around and collect them and then binder clip it with one of the binder clips from my desk, a binder clips that looks like this. If you could do that and leave it on my desk, I would super appreciate that so that I could grade them over the weekend and not have to wait until
Will you be
Monday.
super mad if we don't?
No, but then I have to do them Monday.